we're given that C right here is the midpoint of AD, and it's also the midpoint of BE. And from just that information, we should be able to prove that AB is parallel to DE. How to do it. I'm going to walk you through a decent strategy for handling geometric proofs, and it basically consists of two things: start at the beginning and start at the end. I'll show you what I mean. Starting at the beginning means looking at the givens and seeing if there's anything we can deduce from that. For example, what is a midpoint? A midpoint means that this point C is cutting these other two lines exactly in two. So one thing I can do is say that AC must be congruent to CD. I can also put little tick marks on BC and CE. Can't put the same tick marks because I don't know that BC is congruent to CD or anything, but it is congruent to CE. Anything else? Well, nothing else from the givens. Maybe something else will crop up later. Let's start at the end. So what do I mean by start at the end? I say start at the end because sometimes it's easier to look at what you're trying to get to and think, all right, well, what do I need to get there? And then what do I need to get there? Rather than working your way, worming your way forwards, blindly feeling your way through 1,000 different pathways and not even knowing where you're going. So let's see what that looks like. So I mark what we're trying to get to, and I'll use a different color because I can't use these yet. These are what I'm trying to get. This is like, there's the lines are parallel. Now, how do you prove lines are parallel? Well, thinking back to what you know about parallel lines, you know you're probably going to be looking for a pair of congruent angles, corresponding angles, alternate interior, and oh ho, if you look at it and think about it, those are alternate interior angles, the one I marked in red. There's the pair of parallel lines. There's the transversal that goes from A to D, and those are the alternate interior angles, yeah? So if we could get those alternate interior angles, we'd be set. So I go low down on my page and I note that I'm trying to prove that AB is parallel to DE, and the reason I'm going to use is that alternate interior angles are congruent. I'm doing it as a flowchart proof because that's kind of easiest to follow. So to get to there, I need to say that angle A is congruent to angle D. And how might I know that? You should immediately think, prove triangles congruent. Whenever you need to show lines or angles congruent, show that they're part of congruent triangles. In other words, that horrible CPCTC mouthful. Corresponding parts of congruent triangles are congruent. So it boils down to show that we've got a pair of congruent triangles. Show that triangle ABC is congruent to this other triangle, and the order we have to do it in is we have to show from A to B, we want to go from D to E, and then over to C. So DEC and ABC are the two triangles that we're trying to prove congruent. Triangle DEC congruent to triangle ABC. And now we're back to familiar territory, triangle congruence proofs. So I look at the figure and I scratch my chin and I think, what do I need? I've got a side and a side. If I could just get an angle or another angle, but I can't use these angles that I've marked in red. That's what I'm trying to prove. If I could only get these angles in here, but oh, we missed that at the beginning. That's something we can easily get. It wasn't part of the givens, but those are vertical angles. So we'll call one of them angle BCE, and it's congruent to angle DCE by vertical angles. So we've got a complete path to the proof. We got these 3 steps from the beginning, and that will let us prove the triangles are congruent, which will let us prove this, which will give us what we want. So now it's just a matter of writing it out. All right, and there we have a path from the givens to the conclusion. And all we have to do is either write up that flowchart a little neater or write it up as a 2-column proof. So once again, to do a geometry proof, of course, you got to remember all the factoids you learned in geometry, but it really boils down to 2 things. Start at the beginning and go as far forward as you can. Start at the end and work your way backwards, seeing where you got to go. And if you're lucky, you meet in the middle and can connect everything up nicely.